Usual, before we begin, participants are requested to kindly put their names to login, which you have used while registering. Also, I would like to bring your attention to the feedback form provided during the session, and kindly let us know your opinion, and please don't hesitate to mention if there is any requirement for the certificate of attendance. You can mark up your queries regarding the session in the chat box, which I'll read out at the end of this session. Now, moving on to the session formally, I invite Naurin, IEEE volunteer, to welcome the virtual gathering.
Good evening, ladies and gentlemen. I feel it's my pleasure and privilege to be representing IEEE family and to welcome each one of you to the 88th talk of Inter-Society Weekly Webinar Series Talks. Let me appreciate the efforts of Harindra sir, co-volunteers and professionals of Kerala Section who are supporting this event in making this a huge success for the past 87 talks, bringing out the best profiles and presentation to the virtual room. Moving on to my assigned duty, let me welcome our esteemed speaker, Pamela Kumar ma'am. She is the Director General, Telecommunication Standards Development Society, India, also founding chair and current president of CCICI and the Bharati Chair Visiting Professor at UIET Punjab University, who will be talking about standard-driven research. Welcome, ma'am. Next, I welcome Harindra sir, Chair of Inter-Society, the lead of IWWS to the evening. Welcome you, sir. Next, I would like to extend my warm welcome to volunteers of today's session, Manasa, Hanna Ansar, Amrita Aravind Rushda to the 88th talk. I wholeheartedly welcome all the co-organizing societies, the professional community, and the most charming participants to the wonderful evening. Once again, my cordial welcome to all of you to the 88th talk of Inter-Society Weekly Webinar Series. Thank you.
Thank you, Naurin. Now, I invite Amrita Aravind to introduce our speaker.
Hello, am I audible?
Yes, you are audible.
Okay, thank you. A very warm good evening to one and all present here. Today, we are immensely blessed with the presence of an outstanding speaker, Pamela Kumar. She is the Director General of Telecommunication Standards Development Society, India, also the founding chair and current president of CCICI and Bharati Chair Visiting Professor at UIET Punjab University. An alumnus of PEC Chandigarh, Rutgers University USA, and IIM Bangalore, Pamela brings with her an experience of 35 and more years in the communications, computers, and semiconductor industry, where she led many nascent projects into breakthrough business. Notable among these is the design of the single chip solution for the 2.5G feature phone at Texas Instruments India, which enabled the development of the 1,000 rupee phone, leading to the second Telecom Revolution in India. Pamela has held various honorary positions like Vice Chair of 3GPP-PCG, Member of the IEEE SA Nominations and Appointments Committee, Member at Large IEEE Standards Association Board of Governors, Chair of the IEEE Charles Siemens Awards Committee, Coordinator Industry Relations for IEEE Region 10, Chair of IEEE Computer Society Chapter, and Vice Chair of IEEE Bangalore Session. She holds 3 patents granted by USPTO and has 5 patent applications pending in the networking accelerators domain. We are extremely happy to have you here with us, ma'am. Hope you have a great session ahead with us. Once again, welcome you, ma'am. Thank you and have a great day. Thank you.
Thank you, Amrita. So the wait is over. Now let's all synchronize our attention towards our esteemed speaker, Pamela Kumar. Ma'am, the platform is all yours.
Thank you very much. Thanks for the introduction. And I'll now share my screen. Bring up my presentation. Okay, so today we are going to discuss about standards-driven research. So thanks to the organizers of the event to invite me to this forum. I have, been to Kerala on many occasions. I think earlier I made a presentation also at some events in Kerala. So it's been a good experience interacting with the community there. The enthusiasm and the energy levels are really high. So I feel really happy to be part of this forum. So what I want to focus on is standards-driven research. And this is a term that we have coined and we are trying to drive through TSDSI amongst all the research community. And I think a lot of you here are researchers. So also, as you know, that this Atmanirbhar Bharat, the government is heavily heavily focusing on Atmanirbhar Bharat. In fact, the breaking news of the day is that they have announced almost a $30 billion investment from the government in the semiconductor industry to boost the semiconductor manufacturing and the overall semiconductor ecosystem to make India a kind of a leader in semiconductors. So I think these are exciting times. And standards have a very important role to play. And that's what we're going to talk about today. So what I want to do is, as I said, a call to lead the change. So there's a huge change being driven across the country. And let's dwell over that for a little while. What is this opportunity, especially for engineers? And why do we need India specific standards? So we are always used to standards being defined by somebody somewhere and then just using them. Why do we want to get involved in standards definition? Let's spend some time on that. Then I'll explain to you what the standardization life cycle is, the global landscape on standards. And then there is a snapshot that I have about what China did. Out of nowhere now they are a leader. They are dominating the 5G standards. This part I will actually I have put it in the backup slides. I've moved it for the paucity of time, and maybe we can refer to it if we have time. Otherwise, I would encourage you to look at that. And then we'll spend some time on what's happening in India and how you can participate. So let's look at what's happening. What is changing, right? What is changing for us? What is changing across the globe? So life the way we know it, right, is changing. And this whole slide on Atmanirbhar Bharat Abhiyan very nicely captures it. They're talking about economy, infrastructure, demography, and demand. But at the middle pillar is the system technology, systems and technology driven. So technology, earlier there was the digital India, and now we have technology as the middle pillar of what, the whole transformation and the socio-economic development of India is related to. So technology has a very key role to play for us. And it's, as they said, bold reforms, transformational reforms are the need of the hour. And we are seeing more and more of these reforms taking place. So technology is the new pillar. And what is happening in the world of technology? In the world of technology, there is a lot of convergence happening. The stack, which starts from the basic semiconductor technologies to all the different application areas like robotics and Internet of Things or social media, and powered by communication technologies, converged systems, cognitive computing, cloud computing, artificial intelligence. So all of these are basically now building blocks. They used to be seen as verticals, but now they are building blocks, trying to solve problems, trying to drive solutions and use cases. And that's essentially what 5G is doing. It's bringing the convergence of all these technologies. And the other thing that's changing around this convergence of technology is the way that people interact, right? The way the ecosystem interacts and develops solutions. So there is these open platforms are becoming very common. So IEEE is one such open platform, but open innovation, open source development, open standards, open data, use of open data. This is becoming, and that's really accelerating the way technology is impacting our lives and the reach and really bringing the world closer. So then let's look at some of these applications of technology that we are talking about in the 5G and beyond, and the advanced 5G era. What are some of these new things that these convergence of technologies is going to enable? So we are looking at AR assisted design, augmented reality assisted design. What does that mean? You remember earlier when a house would be, a design architect would design a house or any building, there would be these blueprints, and now everything is done virtually, right? There are these virtual images. You can actually take a whole tour through the house and everything. And this And lo and behold, this can get translated to inputs to a 3D printing machine, which can even do construction. So 3D printing construction is also a vision that this thing can enable, right? We are talking about telesurgery, where surgeons are remotely, using robotic arms and using haptics, can actually perform surgeries in remote areas. A lot of telehealth we have experienced in this pandemic era. Similarly, some other applications, cooperative robots, in the smart factories, using drones for different things, agriculture and retail and all that. So interesting applications are emerging, and imagine your imagination is the limit. What you can imagine that technology can do, and you can build use cases. So finally, this the way we live, work, and play, and even the way we are going to war is changing drastically using technology, right? So we're talking about health tech, which is zero touch. We've seen this in the pandemic era. Fintech, edutech, where all your financial transactions, all your education can happen from home. Agri-tech, a lot of use of agriculture technology in agriculture, smart cities and smart villages. Industry 4.0, where most of the workforce, only 25% of them need to come to work. Most of them can work from home, and obviously smart warfare. So this is the drastic change that technology is bringing in the life as we know it. Now let's look back at the telecom revolution and learn from it some lessons which we can use to leapfrog into this changed environment. And so if we look at the telecom revolution in India, way back in the 80s and 90s, there were less than 8 million lines of technology in the country, as far back as even 1994, and 3 million subscribers on the waiting list, because we were importing the central office exchange equipment, the telecom infrastructure equipment, and we could we could afford to grow at only a short rate, because as you can see, $1,000 per line cost, maybe $100,000 per year is what we were putting to be able to add a few more lines. But then what we did was we formed CDOT, and we built the telephone exchange in India, which brought down the cost from $1,000 to $40 per line. And that triggered a landline revolution, which made 50 million subscribers available. And what that made was we created these STD booths, and you could walk and you could make a call. So within walkable distance, there was a telephone available for you to make a call. That's the revolution we did. And the next phase was mobile. And lo and behold, when mobile came, we architected a new way of scaling the technology in the country. And the cost of the infrastructure went down to $15 per line. There was a 1,000 rupees cell phone solution that was put in place. And the second revolution happened, going to about 1 billion subscribers. So, and the cost per minute was drastically reduced, the cost of per call. So as you can see, while we were doing this revolution, okay, the next point to ponder on what I call the hockey stick of the Indian telecom world. Why did it take us so long? So the technology was available, the 2G technology was available in the 2000s in the rest of the world, and early deployment started in India. It took us a long time to figure out what is the right way to deploy it in India, what is the right price point, the right business model, the right architecture, and then it picked up exponentially. Same thing has happened in 4G, right? The Reliance Jio put this native 4G and it picked up exponentially. So what that means is that there is a latent demand, a hunger for technology in this country, and we need to convert this lying down hockey stick to a standing up hockey stick. And the way we can do it is if we participate in the definition of this technology, in the design of the equipment to meet our needs and our requirements, so that when we deploy it in the early stages, then it can meet the needs. Exponential growth needs to happen right at the early stages of deployment. The other point, that we need to ponder on is what I'm calling engineering the future. So if you look at the 5G triangle, 5G is unlike 2G, 3G, 4G, which was basically about what is the throughput that you can achieve, voice and voice plus data, and voice plus data plus video, okay, being available through a phone or a feature phone or a smartphone. Now, when we're going into 5G, it's not just about the phone, it's about so many applications, right? And there is what we call enhanced mobile broadband, machine to machine, which is all these IoT applications, and ultra reliable and low latency communications when you're talking about drones and self-driving cars and a lot of automation and artificial intelligence. Then you look at all the different use cases: smart homes, smart cities, industry automation, right? Self-driving cars, mission critical e-health. So they fit in a different part of this triangle. So enhanced mobile broadband talks about 100 megabit per second. Machine to machine talks about 1 million devices per square kilometer. Ultra reliable talks about and low latency talks about 1 millisecond and 7 nines reliability. So if we want to give these parameters to every application, it will be impossible. It will be very, very expensive. So you need to fine tune the parameters, the metrics that you need to for the application that you want, right? And then you need to build those solutions and the devices and the technology and accordingly. So we have to engineer the future, so to say. So given these lessons, what is it that we want to change? What is it that needs to change in India, right? So India has always been a laggard in adoption of technology. We have always been, the technology gets developed elsewhere, gets deployed, and then by the time we start accepting that technology, it's already hardened. So all we do is we do RFPs. We start acquiring, we do RFPs, tenders, and the vendors tell us what to put in the tender. We release the tenders, we bring it here, we see it's not working in Indian conditions, then we get it modified, and it takes a long time. Rather than that, we should start participating early on. We should define our use cases. We should get demos of technology to understand, to develop these use cases, do POCs, develop our requirements. These requirements will then drive standards. These requirements will lead to interoperability, pilots, and trials in the country. And then we should acquire technology. So we should collaborate and harden and participate in the hardening of technology and the definition and direction of technology development, and then get into acquisition. That's what needs to change, and that's a huge, huge paradigm shift. And in order to make this paradigm shift, what is it about? It's about influencing the direction of technology. It's about doing a leapfrog into the next generation and embracing emerging technologies. And what it needs is, it needs huge collaboration. It needs the government, academia, industry, and startups to come together and work on this. And a body like TSDSI and the standardization framework provides that ecosystem. It provides that platform to enable this huge transformation. So armed with these lessons, let's talk about why do we need India-specific standards. So we all know about the smart cities and all these missions to take India to the next level of socioeconomic development using technology, smart cities, smart infrastructure, smart energy, smart healthcare, the whole Digital India initiative that is being driven across the country, and the smart grid. So all of these have shown that for India to progress, there is a need to leapfrog and embrace new and emerging technologies. In order to realize this, there is the National Digital Communication Policy of 2018, which talks about things like broadband for all, ubiquitous connectivity, looking at 100% connectivity, and of course, it's looking at some of the socioeconomic factors like new jobs, in the percentage of GDP impact, and net positive in exports and imports. And very interestingly, it's also talking about the progress of India on the ICT Development Index. So today India is 134 and they want to leapfrog into the 50th position of this index. So going one level deeper, our bureaucrats have done an excellent job of defining the goals, right? And setting up this policy framework around Connect India, Propel India, and Secure India, right? So, and if we go deeper into the goals for Connect India, you talk about things like 50 megabit per second universal broadband connectivity, 10 gigabit per second for all the gram panchayats, 100 megabits for broadband. So you can see the kind of ubiquitous connectivity that the government is trying to deploy to really provide the infrastructure to take us to the next level. Now, somehow this thing is interfering on the top with the titles. Okay, so India today is consuming the maximum data, right? It's probably the most fertile market for 5G adoption. And why do I say that, right? 14 gigabytes per user per month is our consumption. And if you can see the exponential growth that has happened, right, on the number of petabytes that are being consumed in the country per month, from 49 petabytes in 2013 to 9,762 petabytes. So the other thing is, when new technology gets introduced, the adoption is very rapid in India. So 90% of the devices sold in 2017 were 4G. So 4G just got introduced and everybody started getting a smartphone. 65 to 75% of the data on these in the cellular network is video, and 90% of this video is in regional languages, right? So you can imagine that every man in the street, every man in the village, everybody is downloading video and watching on their smartphones. Then the rise in internet users, and all these internet users are primarily on the cell phone, not on the laptops. So that's very unique and different about India. So what then is the role that standards should be playing, right? So standards are defined. The whole premise of standards is that, yes, they promote interoperability, they promote integration of services. They also promote things like accelerated deployment, inclusion across this ecosystem, and more importantly, today the standards, especially in the telecom and the ICT world, are very much driving innovations that matter. So the standards framework, which is looking 10 years ahead, we are already defining what will be the technology deployments in 2030, right? What will be the telecom or communication infrastructure in 2030? So it kind of steers innovation in a way that can enable that vision of 2030, and hence innovations. Otherwise, you can innovate and nothing really happens with it, right? Innovation for the sake of innovation. This is innovation for the sake of impact, is what standards enable. And hence they are driving the direction of technology. So that's why it's important for research and standards to come together. We've already talked about this, so I'll skip this. And let's look at something else, right? Why do we need India specific? What's unique about India? So when we are deploying technology in India, let's look at some of the basic data here. You look at area. If you most technology is being developed by requirements of North America and Europe. Early deployments happen in North America and Europe. Their area is 34.89 million square kilometers. India is 1/10, 3.2 million square kilometers. But when you look at the population, if you add the population over that area, they have 1.323 billion, and India is 1.3, exactly the same. So 10 times more dense is the population, which means any technology you deploy, the density will be higher. So we have to design, we have to build standards, we have to design equipment which can meet this, this hyper density. Then let's look at GDP. Our GDP is 1/20th. That requires us to build affordable technology. Oh my God, it's already 6. Okay. So, yeah. So then let's look at power consumption, the carbon footprint in our country. So the average watts consumption in the US is 1,378. And in India, it's 87. Around a 15 times differential. Now, if for India to enjoy the life, the quality of life enabled by technology that is being experienced in North America and Europe, if we want the same quality of life, the same lifestyle, can we afford to make the carbon footprint same as that in Europe and America? No. If we do that, the whole world will fry, right? So we have to develop technology differently. We have to focus on low power. We have to focus on green technology solutions. So these are things which are fundamentally unique, and that's why we need to participate in the development of standards, in the development of new technology, which will ensure that we can leapfrog and in socioeconomic development also. And then there are other unique challenges in India, like rural broadband, right? So 70% of our population lives in the villages, and fiber is being laid out to the gram panchayats. So this is a very important criteria in enabling communication, which is very different from what may be happening in other worlds which are more urban. They have only 15-20% of their population living in villages and 70% living in the cities. So diversity of language, culture, diversity of the last miles. Look at our cities. You have these big software technology parks, and then you have slums right next to them. You have these gated communities with the low cost housing next to it. So different requirements within the same jurisdiction, and different needs that they have. In fact, the people in the slums or the low cost housing may be consuming a lot more video and communication than the people in the 5-star gated communities. So that needs to be addressed. Geographical, we know the geographical diversity, and the rest I have spoken about. So I think it's a pretty convincing story on why we need to participate in standards and early stages of technology development. Here is an example, right? The 5Gi and the low mobility large cell things that we have made happen from TSDSI at ITU. So when we were sitting in the ITU meeting where the 5G requirements were being put together, what is called IMT 2020 in the ITU jargon, right? They were talking about rural broadband. So before we go there, let's understand what's happening in India. In India, there is fiber to every gram panchayat. The distance between gram panchayat to gram panchayat in the base station to base station could vary from about 6 to 12 kilometers. And each gram panchayat serves a lot of smaller villages, right? So when we were sitting in ITU and they were defining the various use cases, especially the rural use case, which is called rural EMBB, they had 2 configurations. And these configurations were coming from North America and Europe, saying that we have highways of 125 kilometers per hour, high-speed vehicles going through these highways, and we want uninterrupted 5G broadband at 100 megabit per second to the people sitting in these vehicles. China was talking about bullet trains going through their villages at 500 kilometers per hour, and they want uninterrupted 5G to those consumers. We said 70% of our people are living in villages. We don't care if they are traveling, even 30 kilometers per hour is good enough. Even static fixed wireless is good enough. But what we care about is that the intersite distance, the distance between the base stations has to be at a 6 kilometer radius, which then brings you 12 kilometers, right? So that was our need and our requirement. And we had to, do a lot of work to get it incorporated into the requirements. Once this was incorporated in the requirements, there is technology that has been developed in our IITs and patented by them, which is called the pi by 2 BPSK waveform and some other additional enhancements that I mentioned here, which we had to get incorporated as a specification in what happened? I have to exit this just a minute. Okay, that was a indication that my other meeting is starting. Okay, so this is what happened there. And we have been able to, I think you must have seen the news on 5GI. Now 5GI is getting merged into 3GPP, and this is going to be the standard of deployment in India. But these were India-specific needs that we brought into the global platform. Similarly, there is NAVIC. NAVIC is from ISRO, our satellite research organization. They had deployed these satellites in the space to provide a navigation system called, which is far more superior to GPS, but they were not being able to commercialize this. And it's only when we brought it to 3GPP, got it incorporated as a standard, that now, commercial chips are being developed, and it's going to be incorporated into all kinds of vehicles and devices to provide navigation based on NAVIC, which is an Indian technology. Okay, so this is what the journey is, right? In terms of, and this is why it is important for us to participate in standardization. I will skip the life cycle thing and just go to the last slide, which talks about standard driven research. Okay, and what I want to emphasize here is that what is standards driven research? When you are trying to think of a research problem or a problem statement for your PhD, I would say participate in the standards discussions, which are looking at technology 10 years from now, and try to incorporate that thinking and that learning into the definition, find a problem which will fill one of the voids here, so that you can contribute. So when you are doing your research and innovating, then you can take these contributions and contribute it to standards. So standards driven research and research driven standardization, right? That is the cycle in which we need to get. And if you look at what it takes, right? Today, our research community focuses on publications. They need to also focus on patents, and the effort that it takes to for a patent compared, I would say, 10 publications worth of work is required to do one patent, and 10 patents worth of work is required to do a standard. So to make a contribution to standards, it's a multi-year journey, and you need to persist. You need to understand that whole big standard, ecosystem, and position yourself within it. So that's the kind of effort that is required. But this is real stuff. That's when you will get the satisfaction that your innovation is actually going to benefit humanity and going to actually see the light of day. This is just to say that TSDSI is well positioned in the global ecosystem of all the key standardization bodies. We have a place in the seat at the global level across all of them. So we will enable you to participate in this. The remaining slides I will leave for your reference, which talk about ITU, some of the work happening in TSDSI, then 3GPP, what is 3GPP as a body, and the various study groups and working groups and what is happening there. Similarly, 1M2M, which is more on IoT and M2M related interoperability standards. And they create this common services layer through which interoperability can happen. That's the focus of 1M2M. These are the features in its various releases. Here is what TSDSI has been contributing to these international platforms. And this is where, some of the other initiatives happening. There was a 5G India high-level forum, which looked into how to develop application layer standards, use case labs, increasing participation in international standards. And here are some slides which elaborate that. They will also set up a 5G test bed, and now already work has started on the 6G forum. So this is time for you to, come and engage with us so that you can start participating in the 6G journey, We're already making contributions. These are just reference slides about what's happening inside of TSDSI, detailed topics which are already in discussion right now, our roadmap, and a huge effort going on 6G. We are already making contributions to the vision document of 6G in ITU and 3GPP. And here are some of the topics that we are, and we would encourage you to start doing research in these areas if you want to become part of the 6G journey. And then that's what I wanted to say. Come join us and participate in this. So thank you.
Okay, thank you.
Yeah.
Okay.
Hello.
If anyone have any queries, you can raise your queries in the chat box.
I hope it was
Yeah.
audible and clear. Or was it?
Yes,
very
ma'am,
rough?
that's audible. Yeah.
Okay. Does anybody have any questions? Or maybe I should ask some questions. Has India started implementing 5G? So 5G trials are already on. And I think they were supposed to be completed in December, but the operators have asked for another 6 months extension. So there are 5G trials going on in, I don't have the list in front of me to read it out to you, but there are trials on 5G which have already started in the country. What will be the transformation time from 5G to 6G? So what is being realized is that 5G had a very, big vision, right, of transforming all the vertical industries using all these technologies. The current 5G specifications have been able to address what we call the enhanced mobile broadband applications. The applications related to ultra reliable and low latency and machine to machine are not fully envisioned. So there's an intermediate step of 5G advanced, which is likely to happen. So right now, 2022, 2023, we will start seeing deployments of 5G. Maybe in the 2025, 26 time frame, you will see advanced 5G. And the time frame for 6G is being talked about as 2030, but the momentum that is coming around 6G is so huge right now. People are saying that it may actually happen faster, and in the beyond 6G world, they will no longer have the 10-year cycle. There may probably be a different kind of model that we may have to move to. So the thrust on moving to 6G is huge. There's a lot of momentum in the overall in the global ecosystem. It may happen faster than we think.
Okay, thank you, ma'am. I hope there are no more queries. This was really a great interactive session. And now I invite Rushda Shaju, IEEE EMBS volunteer, to deliver the vote of thanks.
Thank you. A warm, cherished evening to one and all. Most valued Honorable Speaker, Ms. Pamela Kumar, all other esteemed dignitaries, and dear participants, I, Rushda Shaju of TKMIT, is privileged to propose a vote of thanks and acknowledge the contribution hard to make the 88th talk series. On behalf of IWWS, I give a really heartfelt word of thanks to our speaker, Ms. Pamela Kumar, who spent her busiest time gracing the occasion. Today, we had the opportunity to hear your thoughts, and this is definitely encouraging us in our future events. Your thoughts had enlightened our minds and shown us a new path. As a token of love and honor, we would like to present you a virtual memento. Kindly accept it, ma'am.
Thank you. Thank you very much. And if anybody has any afterthought questions, you are most welcome to connect with me, over email, and I'll be happy to address your questions. And if any one of you wants to join the standards journey, please reach out to us. We'll be happy to involve you in the standards activities.
Sure, ma'am. A special mention to Harintilal sir, respected chairperson of IWWS, being the catalyst that inspired us to do our best and stand as a pillar of power. With deep sense of appreciation, we thank you, sir. I would also like to express our sincere gratitude to the people who work behind the scenes, especially Ms. Manasa, Ms. Welcome Speech, and Ms. Amrita, who gave thanks to us gathered tonight. Your active participation
Thank you, Rishita. As we have come to the end of the session successfully, I would like to announce the next session in the Society Weekly Webinar Series. That is the finale of our talk shows during the COVID, which contains the appraisals by the representatives of speakers, organizers, participants, and volunteers on 22nd Wednesday, 2021 from 6 p.m. to 7:30 p.m. Attendees kindly take a note on that and stay tuned for that session. Hope to see you all on next Wednesday. On behalf of IWWS team, thank you from the bottom of our hearts for joining with us today on this 88th talk. Goodbye, and this is Hannah signing off.
Okay, thank you very much.
Thank you, ma'am. It's a great presentation by you. And thank you for the invitation for the joining to your standards with great of you. I would like to thank Professor Lilikutti of NITC for introducing you to another great personality to our talk, bringing another dimension to our presentation. We are reaching the 2-year slot, 2020-21. We started the program from April 15, 2020, and now this is 88th talk. By the end of this year, we will be completing 90 talks, and we have a total participants of nearly 8,000, and the maximum of 250